In this video, we're going to talk about the chi-square test of independence, and we're going to use Statdisk in order to perform our calculations. Let's begin by talking about the requirements to perform the test of independence. First of all, it is going to involve multiple qualitative variables. Remember from previous discussions, qualitative variables only place the data into categories. It does not assign a numerical value to the variables. And we are going to be testing whether two variables are independent. Our observed frequencies are going to have to be obtained from a single random sample. The expected frequency, which is the data count for each item, has to be greater than or equal to 5. And we are going to use a contingency table with a variable in the rows and another variable in the columns. The size is going to be given by R rows, the number of rows, by C columns, the number of columns in our data table. Next, let's talk about the hypotheses for this test. The null hypothesis is always going to be that the variables are independent, which means that the choice of one variable does not in any way affect the choice of the other variable. The alternative hypothesis is always going to be that the variables are dependent. So as an example, if we gathered the ice cream preferences from men and women, the chi-square test of independence is going to be testing whether gender, whether it was a man or a woman, is related to ice cream preference. So we would be looking at something like, do women mostly choose chocolate as their favorite flavor? Or do men normally choose vanilla as their favorite ice cream choice? So let's look at an example that we will then run through Statdisk. So we have the owner of a lab that wants to make sure that his sick leave usage is minimized. And so to do this, he plans on giving his employees a vaccine for pneumococcal pneumonia. But there are difficulties with the production of the vaccine. So there's only enough vaccine to do half of his employees. Note that this forms two groups consisting of those that are vaccinated and those that are not vaccinated. Once the vaccinations are done, the company sent a nurse to each employee that contracted pneumonia to determine whether they got pneumococcal pneumonia or a different form of pneumonia. The data is summarized in the table below, and what we want to do is to use the chi-square test of independence at the 0.01 level to determine if vaccination status and health outcome are independent. Now let's look at this scenario and make sure that we can actually use the test of independence. Okay, first of all, we do have two qualitative variables, and those are health status, which was pneumococcal pneumonia, non-pneumococcal pneumonia, and no pneumonia, and vaccination status, whether they were vaccinated or not. The sample did come from one random sample, which was the workers at the factory. We are testing to see if the two variables are independent. If we look at our table on the previous slide, each frequency is 5 or greater. And in this instance, we have a 3 rows by 2 column contingency table. So we have met all of the requirements for the chi-square test of independence. So we can proceed. Next, we would want to state our hypotheses. The null hypothesis is that the variables health status and vaccination status are independent. The alternative hypothesis is that the variables health status and vaccination status are dependent. So now let's take the data that we just got from the previous table and perform a test in Statdisk. Recall that Statdisk initially opens with the sample editor that allows you to enter any data that you have. So I did enter the data from our table that we were given for the outcomes into the sample editor. And we would then proceed to do the test. So once we have entered the data, we would click Analysis at the top of the Statdisk menu. And when the drop-down comes up, we would choose Contingency Tables. Now at that point, you would see the left-hand side of this menu. And since Statdisk always has 0.05 as the default level of significance, we would need to change that to our value of 0.01. Then we would need to click on the column numbers that contain our data. We would then click Evaluate at the bottom of this screen, and the right-hand side of this table would be populated. Now, the thing to note in this result is that our p-value is 0.0011. The next step would be to state our conclusion. Remember that the conclusion statement has a prescribed format and consists of 3 parts. So the first part is a comparison of the p-value and the level of significance. The second part is whether the null hypothesis is rejected or not. And the third part is to say which of those 2 hypotheses the data supports and give a verbal statement for that. So in this instance, our conclusion statement will read, since the p-value of 0.0011 is less than the level of significance of 0.01, the null hypothesis is rejected. Therefore, the data supports that health status and vaccination status are dependent. And what that means is whether the employee was vaccinated or not does influence their health status.